as past living environments and habitats, don't they? But when you look at a rock bed, do you see all the palm trees growing and the sandy beaches of the environment that was supposed to be there? No, you see a rock layer with dead things in it. That's all you see. So when was the last time you saw possums and whales living together? No. Again, all we can say, this is where they are buried together. Well, how did they get buried together? What would cause a whale to be buried with a possum? A whale lives out in the deep ocean, so it had to be something that affected both the deep ocean and the land at the same time. Get the picture? It had to be a catastrophic global flood that affected both the deep ocean and the land. Isn't that the kind of evidence we'd expect to find? Of course it is, and we find it. Here's another example. This will blow your minds. Trillions of microscopic marine creatures, plus large coiled shells called ammonites and other marine creatures. In fact, we even find a dinosaur fossil in the chalk beds. And I'll show you an example in a moment. Think about another fossil deposit we find all around the world. Trillions of tons of buried vegetation in the world's coal beds, found on almost every continent. Even in Antarctica, they have coal beds. Here's from the chalk of England. Here's this large coiled shellfish, an ammonite. That example there is about 2 feet across. In the Netherlands, they actually found a dinosaur fossil in the chalk beds. But what is the chalk mainly made up of? Microscopic, tiny shellfish. That's under the microscope. And the geologists say it was shellfish by shellfish that died and sank to the bottom of the ocean over thousands and thousands and thousands of years it took to lay inch by inch by inch. Well, how long did the ammonite fossil have to sit there waiting to be buried? Or the dinosaur? It had to be catastrophic. All these critters, there were huge algal blooms, these blooms on the ocean during the flood because of all the chemicals that were in the water. They proliferated and whoosh, they died out and they buried these other creatures with them catastrophically. Look at the exquisite preservation of this fossil fish. Its eye sockets, its fins. As I said before, when was the last time you saw the dead fish on the bottom of the ocean waiting to be fossilised? They float where they rot. By the time they get buried, they don't look like that. There's a trilobite. It gets its name. It has 3 lobes, trilobite. It has a tail section, a mid-section and a head section. Notice up on your left there you can see it has 2 eyes. I tell you, this trilobite is very well designed. Its lens systems are preserved for us because they're made of the mineral that makes up limestone, and they've been fossilised and preserved for us in exquisite detail. This is one of my favourite fossils, Morsanites sprigii. It comes from outback South Australia. Figured out what it is, by the way? That's a fossilised jellyfish. Now you know what happens to a jellyfish when it gets washed up on the beach. The sun shines on it, it's just jelly, so it melts. If the wind and the waves crash on the beach, it gets broken up. That's why the geologist who found these fossils, and he found hundreds of them, over 400 square miles in outback South Australia, he concluded that they all formed in less than a day. He's absolutely right. Less than a day. Beautiful preservation. Hundreds and hundreds of these jellyfish fossils. By the way, one fish here didn't get time to finish his breakfast before the 2 of them were buried and fossilised. Could that have been a slow and gradual process? Absolutely not. And I love this because it comes from, it's a photograph on the frontispiece of a textbook on vertebrate fossils and evolution. You know, when this photograph was published in the journal Nature, one of the world's leading scientific journals, comes out weekly, the editor put under the caption, "Time freeze frame." What did he mean? Why? Well, that's an ichthyosaur, a mother ichthyosaur, and she's 6 feet long. So she's not small, she's very large. An ichthyosaur was a marine reptile, so it's not a fish, it's actually a marine reptile. Now notice something interesting. Can you see a protrusion underneath her tail? That's a baby ichthyosaur. 1 minute mother was giving birth to a baby, next minute buried and fossilised. She didn't even get time to escape before tons of sand and mud went whoosh. She was buried alive. No wonder the editor of Nature had to be honest and said that this was a time freeze frame. Catastrophic burial, exquisite fossil preservation. The fossil record has abundant examples. We don't have to be embarrassed to talk to people about a global catastrophic flood. What other evidence would we look for? We'd expect to find widespread, rapidly deposited strata or rock layers. And what do we find? We find rock layers that can be traced all the way across continents and even between continents. Why should we be surprised that the evidence in God's world agrees with exactly what we read in God's Word? We also find physical features in these widespread rock layers that indicate they were rapidly deposited. Let me give you some examples. The Coconino sandstone, the Redwall limestone, the Tapete sandstone, 3 rock layers in the Grand Canyon. Here they are in real life. The Coconino sandstone is that creamy coloured sandstone in the rim. We've met the Redwall limestone halfway down, and the Tapete sandstone is that little cliff down the bottom. And what do we find? We find that these 3 rock units belong to 5 sequences of strata or rock layers that can be traced right across North America, right across the country. Let me give you an example. That's the Tapete sandstone and its equivalents. Can be traced right across the United States and all the way up into Canada. Why should we be surprised to find that there's a layer of sand that goes right across the continent? Widespread, rapidly deposited rock layers. You know, the Redwall limestone that you saw before with those nautiloid fossils in it? The same limestone is found in Tennessee and Pennsylvania and all the way over in England. I had a friend with me in the Grand Canyon a few years ago from England, a geologist, and he was amazed. He says, this is exactly the same limestone with the same fossils that we've got over in England. Right across continents and between continents. And the chalk beds I told you about before. Most people don't realise that those chalk beds that we see on the southern English coast can be traced right across to Northern Ireland and the other way across Europe underneath Germany and Poland, all the way down to Egypt, Israel, Turkey. We can even find it in Kazakhstan. The same limestone with the same fossils is found in the Midwest US from Nebraska to Texas and over in southern Western Australia. The same fossils, the same rock layer above, the same rock layer below, the same chalk beds. And it's all full of these trillions of tiny shellfish fossils. That's a global deposit of a rock layer containing a fossil graveyard. What more evidence do you need of a global catastrophic flood? Well, let's have a look at the Coconino sandstone. It's an interesting sandstone. It's 315 feet thick, and in it has some unusual features. We call these crossbeds. The layer of sand is horizontal, but you've got these slanting patterns running through the sandstone. What do they mean? What are they? Well, we call them crossbeds, and how do they form? They're actually the remains of underwater sand dunes. Underwater sand dunes. And here's a diagram to show how they form. You have the sand being carried along by the water, and it mounds up and it keeps on moving and moving, and each current comes along and the next layer gets layered on top of the next one. We can actually see this similar sort of process under the Golden Gate Bridge of San Francisco in the channel there. You know, the Coconino sandstone also covers hundreds of thousands of square miles. And we can put all this information together. The average thickness is 315 feet thick, covers an area of more than 100,000 square miles at least. Some suggest it could be double that. The volume of sand is at least 10,000 cubic miles. Some suggest it could be double that, 20,000 cubic miles. And it was deposited as multiple sheets of these sand waves or underwater sand dunes up to 60 feet high. We can work that out experimentally by looking at the evidence in the rock. Moving along by water, moving at 3 to 5 miles per hour. Now you might think that's slow, but at that rate, the whole sandstone bed would be formed in just a few days. Over 10,000 cubic miles of sand transported and deposited over 100,000 square miles in just a few days. So it only takes a few days for this layer, a few days for that layer, a few days for the next layer. The sum total of all the layers in the Grand Canyon isn't millions of years, it's just a few weeks, in fact. Well, let's go back to Australia, in the centre of Australia. Some of you have heard of Ayers Rock or Uluru. It's actually a giant sandstone bed that's been tilted upright. It's poking up vertically out of the ground and it's been eroded. And we can get different views. You can see those sandstone layers or sticking upright, these sandstone beds. The total thickness of these sandstone beds is 18 to 20,000 feet. It's not all exposed. Some of it has to be discovered by drilling in the surrounding desert sands. Now this sandstone is very interesting. We can look at it under the microscope and we can actually see the evidence that this sandstone bed was formed very rapidly. Look at those sandstone grains. Notice they're all different sizes. Notice that? There's little ones, big ones. Ever tried an experiment where you got a mixture of sand and mud and water in a jar and shook it all up and let it settle down? What happens? It separates to the large grains at the bottom and then the finer grains at the top. Over time. But here we have a mixture. What does that tell us? Big grains and little grains all mixed up together means that there was no time for them to separate into their grain sizes. See, it doesn't take much logic to figure these things out. Notice something else. A lot of those grains have jagged corners on them. See that? Some of those grains have got pointy corners. Now what happens when, well, we go to the biggest scale? Let's take pebbles rolling down a riverbed. What happens to them? Are they all jagged? No, they get rounded because they bump into one another and then edges get knocked off and they get perfectly smooth with time. But if there wasn't time, what would they be like? Jagged. You see how easy it is to see the evidence? Jagged grains mean there was not sufficient time for them to be rounded. So there was no time to sort them and there was no time to round them. The third observation is not as obvious to you as it is to me, but you can see on the right-hand side a grain that has got all these stripes in it. That's a particular mineral that is unique to this sandstone that's not found in many others. It's a mineral called feldspar. And it doesn't, why is it in most sandstones? Is because it disintegrates very rapidly. These sandstone layers or beds are now tilted at about 80 degrees. The total thickness of these sandstone layers is about 18 to 20,000 feet. That's about 3 to 4 miles. The sand grains were eroded and transported at least 63 miles. The jagged grains, the different sizes and the fresh feldspar implies rapid transport and deposition. It all happened in a matter of hours. Sediment slurries travelling at 70 miles per hour would have been responsible for depositing these 3 to 4 miles thickness of sand beds in just a couple of hours. Remember what we said before? If the water currents go over the continents, they're going to carry that sand and mud and lime long distances. Well, let me give you an example. The sediment in widespread rapidly deposited strata had to be eroded from distant source areas. What do I mean by that? We'll come to it in a minute. Rapid or no erosion between strata. We wouldn't find evidence of millions of years between the rock layers, as many geologists claim. We'd either find evidence of only rapid erosion or no erosion between the rock layers. So the examples will illustrate this very, very well for you. My first example again is the Coconino sandstone. It's made up, you saw how white it looked, it's made of pure sand. And it had to come from a far distant source. Why? Underneath this pure white sandstone, we have this mud rock called the Hermit Shale. It's reddy brown. It's composed of silt and mud. So, could the sand in the sandstone have been eroded from that shale? No, it's a different rock altogether. Everywhere we find the Coconino sandstone, underneath it is the Hermit Shale. And it stretches for mile after mile after mile. That means the sand which makes up the Coconino sandstone had to come from further away than from every outcrop where the Hermit Shale is underneath. And that happens to be way up in the north of the US. So it had to come all the way from the north of the US down to the Grand Canyon area, a long distance of sediment transport. I'll give you another interesting example. Even the conventional scientists now suggest that the sand grains making up the Navajo sandstone, which we find in Zion National Park higher up the sequence in southern Utah, was transported all the way across the United States from the Appalachians. Only a global flood could carry sand grains that far right across the continent. In fact, in the rock layers we find water current direction indicators like ripple marks. Those cross beds that I told you about, the evidence of the sand waves, they indicate the directions in which the water was flowing. And the evidence in the rocks throughout the walls of the Grand Canyon and right across North America, in fact right across South America, is that the water, for supposedly 300 million years of conventional thinking, was always flowing from northeast to southwest across those two continents. Of course it wasn't 300 million years. What about rapid or no erosion between rocks?